All right, guys. Last part of this part of matrices, these lessons with matrices, we're going over inverses, finding the inverse of a matrix in systems of equations. Now we determine, or you're able to determine if two matrices are inverses if we multiply the two together and get the identity matrix. So the identity matrix is this here. Gives us the same thing. So if we multiply two matrices together and we get the identity matrix, it means that those two matrices are inverses of each other. So here, if we want to determine that these two matrices here, A and B, are inverses, all we need to do is multiply them together. All right, guys. So, all right, guys, let's focus in here. So when we multiply, we're going to go over and down. So we're going to go over and down. So we'll have negative 4 times 1/4 plus 2 times 1/2. Then we'll do the same thing over and down. So we'll have negative 4 times negative 1/2 plus 2 times negative 1. We'll do the next one over and down. We'll have negative 2 times 1/4 plus 1 times 1/2. And lastly, over and down. We'll have negative 2 times negative 1/2 plus 1 times negative 1. Now at this point here, we can simplify each of these here. So negative 4 times 1/4 is going to be negative 1. 2 times 1/2 is also going to be 1. So we get negative 1 plus 1. Negative 4 times negative 1/2 is 2. Positive 2, and 2 times negative 1 is negative 2. On bottom, we have negative 2 times 1/4, which is going to be negative 1/2. 1 times 1/2 is going to be plus 1/2. Negative 2 times negative 1/2 is going to be positive 1. And 1 times negative 1 is negative 1. At this point here, negative 1 plus 1 is 0. 2 minus 2 is 0. Negative 1/2 plus 1/2 is 0. And 1 minus 1 is 0. So the matrices this gives us is 0, 0, 0, 0. Now for them to be inverses, we need the identity matrix, which for a 2 by 2 is going to be 1, 0, 0, 1. And if it's not this exact matrix, they are not inverses. So A and B here are not inverses. Because we did not get the identity matrix, it means they are not inverses. And that's it. Questions on this here? All right. Now we have this one here. As we've done so far, we know that we can type these in the calculator, especially with addition, subtraction, multiplication, division. So if we wanted to type this one into the calculator, we would type F in as A and G in as B. So we go second matrix over to edit and define it as a 2 by 2. Now this first matrix is kind of nice. 3, -5, -2, 6. Able to get the first one typed in. Okay, second matrix. We're going to go over to edit and we'll plug it in as B. So 2 by 2. Now the first one we have is 3/4. Now there's two ways we can type it in. We can do alpha y equals enter 3/4, or we can just say what? 3 divided by 4. Because again, we're not trying to get fractions. We're just trying to see if they're inverses. And even if we do need the answer in fraction form, not decimal form, math, enter, we'll turn it back into fractions. Our next one is -1/6, -1 divided by 6. The next one's 1/4. And lastly, 3/8. So we can use alpha y equals enter or just type them in as division. Probably a little bit quicker just to do the division. Questions on how we typed any of this in? So we want to see if they are indeed inverses. And to do that, we're going to take A and multiply by B. And A times B is this here. Let's make sure. 3, -5, -2, 6. I think so.
You said -6 and there's not a -6.
Ah. Yep, so that'd do it.
What I got is 1.
Yeah, 3, -5, -2, 6. Yep. Second one. 2, 2. So 3/4. Ah, that's right there. So 5/8. 1/4. Let's try it again. Yep. 1, 0, 0, 1. And I mean, that's a good case right there, because sometimes if we get funky numbers, I just go make sure, look back at the matrix that we typed in. So A times B gave us 1, 0, 0, 1, the identity matrix. Let's see what B times A gives us. Because as we saw the other day, the order in which we multiply two things can change the outcome. This also gives us the identity. They give us the same thing. So, are these two inverses? Yes. That's it. Questions on this here? Questions on how we figure out if two matrices are inverses? Why not? We can go and plug this in. Second matrix. Edit. 4. -1, 2. Helps if I actually 2 by 2. 4. -1, 2. -2. Second quick. Second matrix. B is a 2 by 2. 1/3. -1/6. 1/3. -2/3. Second matrix A, second matrix B. It does indeed give us the identity. So this is also, yes. Questions on these so far? Yes. So we feel pretty comfortable with determining if two matrices are inverses. All right. We're ready to find the inverse of a matrix. The inverse of matrix A inverse, is equal to, so A to the negative 1 is A inverse, is equal to 1 over AD minus BC times our matrix, where we flip A and D. A and D numbers are switched, and we take the opposite. We flip the signs of B and C. Now, for this matrix to exist, AD minus BC cannot be 0. If AD minus BC is 0, it means that the matrix is not invertible. It does not have an inverse. So let's look at this here. We're going to find the inverse of it. Inverse is our 1 over AD minus BC times our D, negative C, negative B, negative CA. So here, to find P inverse, we have 1 over, well, our A is 7, B is negative 1, minus negative 5 times 2. Any questions on how we did this first part here? AB, CD. Really, what is this first part? First part's just 1 over the determinant of the matrix. Negative 1. Yeah, so really we just have this here. So the negative 1. Are you saying this negative 1? Oh, it's inverse. So it's not P to the negative 1 power, it's just signified P inverse. Inverse function. And whenever we talk about f of x or f to the negative 1, it's f inverse of x. So here we're saying P inverse. P is the normal matrix, P inverse is its inverse. Now the matrix itself is going to be changed a little bit. First thing we're going to have is the 7 and negative 1 are going to switch places. And the other piece is that the 5 and negative 5 and 2 are going to switch signs. Since the 5 is negative, was negative, it's now positive. Since the 2 was positive, it's now going to be negative. Now all we need to do is simplify that fraction in front and then multiply through. Well, 7 times negative 1 is negative 7. Minus negative 5 times 2 is negative 10. Well, the negative negative makes a plus 1, 5. And negative 7 plus 10 is 3, so it tells us the fraction out front is 1/3. And last but not least, we need to multiply through. 1/3 times negative 1 is negative 1/3. 1/3 times 5 is 5/3. 1/3 times negative 2 is negative 2/3. And 1/3 times 7 is 7/3. So our P inverse, the inverse for this function here is negative 1/3, 5/3, negative 2/3, 7/3. And that's it. Questions on this here? Really, we just plugged it into the formula and simplified. We're ready to look at the next one. All right. Let's look at this one here. So we're told Q is -8, -6, 12, 9. To find Q inverse, we're going to take 1 over -8 times 9 minus -6 times 12. And inside the matrix, we switch the 9 and -8, and we flip the sign of our other 2. So the -6 is going to become positive, and the positive 12 is going to become negative. Now, before we can do anything else, we'll need to simplify that fraction. -8 times 9 is going to be -72. Minus 6 times, or -6 times 12 is -72. But our minus and negative is going to make a plus. And -72 plus 72 is?
0.
I think we have an issue. There's no way to divide 1 by 0. So the inverse doesn't exist. So we could say that the inverse doesn't exist, or it's not invertible. Inverse doesn't exist. There is no inverse for this function, because the determinant of this function is 0. There is no inverse. So we can't find the inverse. Questions on this here? Now we have a feeling probably there's a way to do this in the calculator, yes? All right. So let's look at the next problem. Second matrix over to edit. Now, if it's going to have an inverse, it's going to be square. It has to be a square matrix for it to be invertible. And the next one we're looking at is 3, 7, 1, -4. 3, 7, 1, -4. So we type it in. Second quit. Second matrix A. So we typed it in, and we're going to recall it. Well, our inverse, we've been saying, is what? To the -1, yes? The matrix button without hitting enter is to the -1. That's not a nice number. But if we go math, enter, enter, it tells us it does indeed have an inverse. And its inverse is 4/19, 7/19, 1/19, and -3/19. That's it. Math, enter, enter. You get it? Okay. Questions on how to find the inverse? All right. Now we can solve a system of equation using inverses. So what we do is we take the system of equation and split it into 2 main parts. The first matrix, A, is the coefficients, the numbers in front of our variables. And we're going to multiply it by the matrix X, which is X, Y, a 2 by 1. Because if we did this multiplication, we would go over and down, which would do 1 times x, which is 1x, plus 2 times y, which does get us back to our equation. And when we multiply it out, so a times a inverse. A inverse times a. Well, as we said already, if we want to make sure the two matrices are inverses, we multiply them together, and their product is the identity matrix, which is just 1. And when we multiply the inverse of our original matrix by b, what they're equal to, that solution, that product, will be the solution to the system of equations. So what we have to do for this here is find the inverse and multiply it by the other side. Because what we do when we break this down, we'll have the coefficients, which is negative 7, 2, 6, and 6. And this here is being multiplied by our matrix xy. Because when we multiply these two here, really we're going to get these two expressions here. And we set it equal to a 2 by 1 of what each of these equations is equal to. Questions on this here? Now the key thing we need to find at this point is the inverse of this matrix here, because we're going to multiply that inverse on both sides. Because when we find, we'll call that A, and this is B, because we have A times our xy is equal to B. Because if I'm able to find the inverse and multiply it by this matrix A, those are going to cancel out, those are going to simplify. And if I do something to one side, we have to do it to the other. Now, I have a feeling at this point, I'll grab the calculator, 1 second matrix, edit, 2 by 2. And we have our negative 7, 2, 6, 6. Second, yes. Second matrix over to edit. B is a 2 by 1. Because we do need that original matrix A, but we also need what it's equal to, that B, that 2 by 1. And for his here, B is 18, 0. We're able to get those two matrices typed in. Pretty good at this point so far. Second matrix over to edit. And then we went down to B and plugged the other one in. The 2 by 1. Because at this point here, when we do this A inverse times A, that's going to become our matrix equivalent of 1, leaving us with just xy. On the other side, we have A inverse times our matrix B. Well, for us here, we do have matrix A, and we want to find its inverse, yes? And we want to take what that inverse is and multiply it by B. So we're taking A inverse times B, which is negative 2, 2. So what's the x value here? Negative 2, and the y value is? And that's it. That's how we can use inverses with matrices to solve a system. And we can do the same thing with 3 variable systems. Questions on this here? We feel comfortable with this here? All right.